Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back again to this TV learning series program. As usual, I'm Teacher Patrick. This time I'll be taking you through Senior 2. So it is Senior 2, but I also ask even the Senior 3s can follow, because this will be even the revision. Probably there could be even some of you who could have even covered this topic that we are going to go through with you. And you can also be revising with us. So there is no problem. So I'm inviting any class to be available, and please pay attention with your pens, if you have them, and a notebook. So to be precise, we are going to look at the types of the reactions. We are going to look at the types of reactions. When we talk about reactions, we are referring to the chemical processes. And these chemical processes, some of them exist in nature. Some of them, these chemical reactions can also take place in the laboratories. Maybe you can even mention some of the examples that you know, some of the chemical reactions that occur or that take place in nature. Well, these chemical processes, maybe to remind you, we have what we call photosynthesis. At least by this level, I believe everybody knows what photosynthesis is. So this is where the plants make their own food from carbon dioxide and water. So the carbon dioxide, this is, for example, you have carbon dioxide, and it is reacting with water. This takes place in presence of sunlight, and then gives the food, then plus the oxygen gas. So in all the reactions, please, you need to always balance the reactions. So when you write a reaction, you have to make sure the reaction is balanced. So this is carbon is 6. And then we have hydrogens, they are 12, so they have to balance here. These are, so we need 6 to make them 12. The oxygens here, we have 6, and then we have 6 and 2, this is 12, so this makes 18. And here we have 2, and here we have 2, so we need to make them 18 as well. So if we make these 6 molecules, and then these 6 molecules is equal to 18, this is 12, this is plus 4, so we have to, this is 6, 12 plus 6, this is 18. So you have 6 carbon atoms, you have 12 hydrogen atoms, you have 12 and 6, that is 18. So you have 12 and, sorry, this must be 6. Thank you. So that means the process of the process of photosynthesis gives food component, and it takes place in the presence of light. So all the reactions that take place in the presence of light are called photochemical reactions. So we can call this one a photochemical reaction. There are some other processes, chemical reactions. Some of these chemical reactions take place within our bodies. So if those chemical processes happen to stop, then the life will also stop. Give an example of respiration. Respiration is similar to burning of food. And when we're talking about the burning, we are referring to combustion. So that is similar to the reaction with oxygen. So we have this, in here, we have the food, and to be precise, this is a starch, which is converted into glucose for easy absorption. So the starch, or the glucose, is combining with oxygen. This is a chemical process that takes place within our cells. So it is called cell respiration, or sometimes called tissue respiration. So when we talk about respiration, some people or some of the students confuse it sometimes with breathing exchange. So there is gaseous exchange and there is respiration. So the respiration takes place in the tissues. So this is combining with oxygen. And then it produces carbon dioxide and water plus the energy. That is the main important. That is why we take even food. So when you look at this reaction, we have oxygen, or the reactions that when a substance reacts with oxygen, that is, I said we call it combustion, or we can call it burning. So this type of reaction is called, mainly it is called, or in most cases, it is called combustion reaction. This is a combustion reaction. So you can as well have as many combustion reactions. That is one type of the reaction. Look at these two processes. When you look at this one, the first one, this one produces the food and oxygen. So oxygen is very important. So that means the plants that we see outside there are responsible for releasing the oxygen in the atmosphere that we need for our lives. You cannot survive if there is no oxygen, for instance. If there was a problem in the atmosphere and the oxygen concentration levels reduce, then animals would get problems. We are animals as well, so would get problem. So when you look at this process, so this glucose is produced by the photosynthesis, and then because we depend on plants ourselves, we depend on the plants for food. So when glucose is taken in, then it combines with oxygen, produces carbon dioxide and water and energy, which gives us, that helps us to do very many activities, walking, seeing, even when you are reading and thinking, or whichever activity you are doing, you will need the energy. And this is one of the reactions that we can call combustion. Remember, you can also balance the reaction. So, but we can have some other examples as well of the combustion reaction. So we have magnesium combining with oxygen. This is the gas, the solid, and this one will give magnesium oxide. So magnesium oxide is also formed. You can as well have this methane gas. This methane gas is a component of natural liquid, we call it natural liquefied gases. Natural liquefied gases. These are the gases that we use in our homes. Those tanks, one of the components is methane gas. And then it reacts with oxygen, so it burns with oxygen, and then produces the carbon dioxide and water, plus the energy that is produced in form of heat for cooking food, boiling water, and other activities in our home. So it is very important to remember this reaction. So this is also combustion reaction. So taking an example of this one, if you look at this reaction, you have magnesium combining with oxygen to give magnesium oxide. So the product, when you look at that product, it is made up of elements, these two elements combining together, and they are producing one product. So that, in that case, the type of reaction that we can also have that is similar to this one, we can also call it combination. This is combination reaction. So in addition to being combustion, it can as well be combination reaction or synthesis. a synthesis reaction. One product is synthesized or is made or is produced from its elements in their standard states. So when you look at the magnesium, we can have as other examples as well. So you can have hydrogen combining with the oxygen to form the water. Water is made up of these two elements, oxygen and hydrogen combining to form the water. That is one other example of combination or synthesis reaction. So we can as well have either hydrogen combining with chlorine to form hydrogen chloride gas. So this is one component. It is made from two elements. When you look at this product is made of hydrogen and is made of chlorine. These are the elements that are combining together to form this product. So it is also one of the examples of combination or synthesis reaction. There are some reactions which are also very common, as I may call it, and I'm just going to show you this, something very simple here. We have, this is a zinc strip. We can call it zinc plate. When you look at this one, it is zinc plate. And then we'll have a solution. This is just water. I'm just going to make a solution of copper sulfate. Copper sulfate is this one. So I just make a solution of that. And then you will predict what is happening. I will ask you to predict what is happening. I'm just making a solution of copper 2 sulfate. This is copper 2 sulfate solution. I'm just trying to make here. And I'm just going to dip this zinc strip or zinc plate in this solution, and then you'll predict what is going to happen. This is a zinc strip, and this is a copper 2 sulfate. So I have you to just take a close look at what is happening. So the zinc strip is it is actually shiny because it is a metal as usual. But when you look at the metal ready, which is inside here, the metal is changing. So we'll just have to leave it there and just keep seeing what is happening there. So there is copper in there. So when you look at the zinc strip which is there, it is changing. And what is happening? Can you predict what is happening? Well, so we have zinc, which is combining. These are the substances of where this is the reaction. So it is combining with copper sulfate. For example, this is a solution. This was the metal. Now, what is happening here is that after some time, we just have to leave it there. So you'll have the zinc metal disperses this copper from its solution. And therefore, when it disperses, so copper is dispersed as a solid. So we'll have the solid forming on the zinc strip. So it is changing. We have to keep it there for some time as we watch on the reaction going on. So the copper is dispersed, and then you'll have this zinc sulfate forming in the solution. We'll have to keep watching that. Then towards the end, we'll see what will have happened. So that kind of reaction that is taking place here is what we call a single replacement. Single replacement. So the single replacement, you can have the zinc is displacing this copper. So I would have, I can also as well show you another reaction. And then we are just having, this is calcium metal. And then we'll have just little solution of hydrochloric acid. This is hydrochloric acid. So I can just put a little here in the beaker. Then we'll have to put there a little calcium metal. So this is also another example of a single replacement that we can also look at that can help us to understand what is happening. So when you look at this reaction, you see the bubbling of the gas. So that is hydrogen gas that is reacting. This is effervescence. So you can see the bubbles coming up. So that is the effervescence of the gas. So it means that calcium is reacting with HCl, and when it reacts with HCl, so the calcium metal displaces this hydrogen, and then you have calcium chloride plus the hydrogen gas. So that is the gas that is being produced, is just coming out of the solution. So the calcium is used up now. So that is another type of reaction that we can call single replacement. So you can as well suggest other examples, not necessarily only this. So metals, you can have sodium with the HCl. So this will be sodium chloride, or any other acid. Or you can have either magnesium with the sulfuric acid. So this will form magnesium sulfate and hydrogen gas. So these are some of the examples of single replacement reactions. So you can have as many other examples. But for this reaction to occur, this is something very important that you need to note. For these reactions, single replacement that we have seen, these reactions depend on what we call reactivity series. Reactivity series, or sometimes called activity series. So the activity series is the arrangement of metals in order of their reactivity, either with water, either with oxygen, or with acids. So this reactivity series is potassium, I have sodium. I think I can maybe put it on, make it very clear. So you have potassium, you have sodium, you have calcium, magnesium, aluminum, you have zinc, you have lead, or before lead you have iron, you have lead, you have hydrogen, you have copper, you have mercury, and then silver, the last, and that. So this one is showing decreasing is, this is decreasing is of reactivity. What does it mean? It means that as you're moving down, the reactivity of these elements are decreasing. So this is the most reactive. So this is most reactive. And this is least reactive. Least reactive. What does this mean again? It means that any metal, you see where hydrogen is, any metal above this hydrogen can displace it from any solution. If I use an example of this, that was for the acids. If I use zinc and copper, so if you have zinc here, This is the copper. It means that zinc is more reactive than copper, and therefore this reaction can take place. But if you have, for example, copper sulfate, now you have copper plus zinc sulfate. That is an example I'm just giving. This reaction won't take place. This reaction here won't take place. Why? Because this zinc is more reactive than copper, so copper cannot displace it from its solution. Let me just show you even here in the, because I have that copper, I have zinc sulfate with me here. This is copper, yeah, right, there we go. So this is a zinc sulfate solution, rather solid. So I'm just going to make a solution of zinc sulfate, and then I show you what I'm talking about here. This is a solution of zinc sulfate. This is just water. So I add water here. So we don't expect the reaction is going on. Please, as you are following, you need to also look at this one. There is a reaction going on. So I have a strip. This is zinc sulfate solution. Remember? So I'm just trying to show you what the difference between this and this one that we are talking about. So this is zinc sulfate, and I have a copper strip here with me. This is a copper plate, and I just insert it in here. There is no difference. Look at it. This is the reaction we are talking about. This was zinc and copper sulfate. This is zinc sulfate and copper strip. So what is the meaning of this? Why it happens like this is because this zinc is more reactive, so copper cannot displace it from the solution. So this reaction doesn't take place. And that one, as I said, please take note of this one. We said sodium, potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, you're followed by silver, then you have gold. Let me just write it properly here so that you can see it clearly. So you have mercury, you have silver, and then you have gold, and then platinum. Platinum is the least reactive. So this is the continuation of this one. The least reactive element is platinum. So remember what I'm talking about here. So this is another type of reaction that we talked about, so which is single replacement. Let me also do some other simple experiment. You'll predict what is happening. So this is lead 2 nitrate, contains lead ions. It is lead 2 nitrate. This is a solution. And I'm just going to combine it with this is potassium iodide. This is potassium iodide solution. So I'm just going to make a simple, just take a close look here. This is lead nitrate. Just adding that one, very little. And I'm just adding potassium iodide. This is potassium iodide that I've added, and then it forms a yellow precipitate. So when you add potassium iodide, this gives lead 2 iodide, lead 2 iodide. This is solid, plus potassium nitrate, plus potassium nitrate. This is potassium nitrate. So we have a solid that has been formed. This yellow precipitate, I think we have done this, we had even done this one even before. This yellow precipitate is because of this. So when you look at this reaction, please, can you take a look at this reaction? See what is happening. You see this lead combining with the iodide ions. And then you see the potassium combining with the nitrate ions. And then it forms lead iodide and then potassium nitrate. For those probably that could have maybe probably covered this, you still remember this type of reaction? Good. So this type of reaction is what we call double replacement. Double replacement. So in a double replacement, you have two aqueous solutions combining together to produce a solid and another aqueous solution. So a solid is formed from two aqueous solutions, two soluble solutions. You can have even think of some other examples, not necessarily this. Probably you can have another one. I have copper 2 ions. This is copper 2 sulfate solution. And then I will have copper 2 sulfate solution. Sodium, should be having sodium hydroxide. It's here. Sodium hydroxide. That is sodium hydroxide. And I'm just going to mix it with the copper 2 sulfate solution, and see what is happening. We had done this one even before. This is a precipitate that is forming. Precipitate insoluble in excess. We had even mentioned this one some time back. So you have sodium hydroxide is reacting with copper 2 sulfate. If you remember what we did the other time, we were writing only ionic equations. That is very common when we are dealing with the ions. That is very common that we write copper 2 sulfate. This is the solution. And then it is reacting with sodium hydroxide. Does it give here? Can you just predict from what we did here? So you can easily predict from this one. So you expect this one. This is an anion. Oh no, sorry. The sulfate combines with the sodium. So what is happening? The cation of one compound reacts with an anion. So this one gives copper hydroxide solid, then plus sodium sulfate. So with that, or before we wind up anyway, let's have an example of some reactions. Then you'll be able to tell, just an exercise that will be homework for each. So please take note of this. This is homework. Just try to identify for each reaction. For each reaction, identify the type of reaction taking place. So you have sodium chlorate forming, you have silver nitrate, this is number 1, plus potassium phosphate, this will give silver phosphate plus potassium nitrate. Number 2, have C2H2 plus oxygen. That gives carbon dioxide and water. Number 3, nitrogen and hydrogen, giving ammonia gas. So you identify, this is the exercise that you're supposed to do, but before I wind up, I just want to show you what is happening with this. So even when you look at this substance, here there are some particles here. This one is copper. The copper is depositing on this zinc plate. This is copper, the copper metal is depositing on here. So it is changing from zinc into the copper. That is the reaction that we had talked about before. Maybe I can wind up from here. I thank you so much for listening and watching. I hope we'll be together next time. Bye.